When we look deep into space, we expect to find frozen, lifeless worlds. But these new images from NASA's cutting-edge probe have shattered that idea. What we see now are strange, towering structures and violent processes unlike anything we'd seen on Earth. This is Jupiter's moon, Io. It is a world caught in a perpetual violent struggle between fire and ice, making it the most geologically alive body in our entire solar system. While the surface screams with volcanic fury, scientists back on Earth are only just beginning to understand the invisible, chaotic forces fueling this engine. The Jupiter system is practically a mini solar system of its own, boasting nearly 100 officially recognized moons, a roster that keeps expanding as we spot new objects caught in the giant planet's orbit. While the vast majority of these moons are tiny captives, 4 of them are truly massive. We know them as the Galilean moons, named in honor of the 16th century astronomer Galileo Galilei, who first spotted them through one of history's earliest telescopes. The 2 outermost moons, Ganymede and Callisto, are ancient worlds composed of solid ice and rock, their surfaces dead and heavily scarred by craters. Moving inward, we find Europa, a world defined by a thin, smooth shell of ice concealing a global ocean of liquid water, a prime candidate for extraterrestrial life. Then, sitting closest to the gas giant, is Io. Orbiting just 350,000 kilometers above Jupiter's swirling cloud tops, Io is roughly the size of Earth's moon, perhaps just slightly larger and heavier. However, its composition is radically different from its icy siblings. Io is the densest moon in the solar system, built almost entirely from rock and metal. It is an arid world, believed to hold the lowest water content of any known object in our system, making it even drier than Mercury, the planet scorched by the sun. But Io's dryness is overshadowed by the violent action on its crust. Apart from Earth, this is the only place we have found where volcanoes erupt on a regular schedule. It holds the title of the most volcanically active location in the solar system, with as many as 400 active volcanoes pockmarking its surface. We first realized this during the Voyager 1 flyby in 1979. Despite being 20,000 kilometers away and using primitive, low-resolution cameras, Voyager managed to capture 9 distinct eruptions blasting material into space. These raging rivers of lava are even more shocking when you consider the environment they exist in. Away from the volcanic hotspots, Io was consumed by a deep freeze, with surface temperatures plummeting to 130 degrees Celsius. The sun is simply too far away to provide warmth, so the question has always been, where does the heat come from? The answer lies in Io's treacherous location. It sits at a precise distance from Jupiter, close enough to be trapped, but just far enough to avoid being shredded by the planet's immense gravity. However, it is not a safe orbit. Jupiter pulls on the moon with tremendous force, stretching the solid rock and distorting the moon's shape. Complicating matters are the other 3 large Galilean moons. While their gravity is weak compared to Jupiter's, they exert a rhythmic pull in the opposite direction, disrupting Io's path. Instead of a perfect circle, Io is forced into an oval-shaped orbit. This means that during its cycle, which takes about 2 days, it swings closer to Jupiter and then further away. It never experiences a steady gravitational pull. It is constantly being stretched and then released, changing its physical shape as it moves. The result is a phenomenon known as tidal bulging, but on a scale that dwarfs anything seen on Earth. On our planet, the moon's gravity pulls on our oceans, causing tides to rise and fall by roughly half a meter in open water. On Io, Jupiter's gravity is so intense that it lifts the solid ground by as much as 100 meters when the 2 bodies are closest. This isn't water moving. This is solid rock being heaved up and down. This relentless stretching and squeezing acts like a planetary pump, generating massive friction deep inside the moon, which transforms into the heat that powers its volcanic fury. The volcanoes produced by this process, however, do not behave like the ones we know. On Earth, volcanoes usually form mountains at the edges of colliding tectonic plates. Io has no plate tectonics. Instead, the constant gravitational flexing cracks the crust, allowing lava to fountain out from the interior. These eruptions are explosive, throwing lava dozens of kilometers high, while plumes of sulfur gas can rise for hundreds of kilometers. This sulfur is the key to Io's appearance. The gas creates a tenuous atmosphere that fluctuates in density, sometimes a third of Earth's density, sometimes double depending on volcanic activity. As the sulfur settles back onto the surface, it paints the moon in vibrant colors. The yellow regions are crystallized sulfur, essentially sulfur snow. The white and blue patches are frozen sulfur dioxide clinging to the coldest shadows. Green areas mark where sulfur monoxide is interacting with Jupiter's radiation belts, and the red splotches are the hot spots of recent eruptions where the sulfur is still being cooked. Interestingly, this volcanic activity rarely builds mountains. After an eruption, the surface tends to collapse, creating vast depressions that fill with molten rock. These become lava lakes, like the famous Loki Patera. This lake spans 200 kilometers in diameter, featuring a solid island of rock floating in the center of a churning magma sea. For a long time, we wondered what lay beneath this crust. Gravity measurements from passing probes have revealed an uneven gravitational pull, suggesting that the magma isn't a uniform global ocean. Instead, it seems Io is honeycombed with isolated pockets of molten rock, hundreds of separate volcanic engines hidden underground, specifically in areas where the tidal flexing is most extreme. But recent discoveries have deepened the mystery significantly. If we accept that the volcanoes on this moon do not function like ours, meaning they don't build up layers of lava to form peaks, then how do we explain the existence of Steeple Mountain? This bizarre geological structure has become one of the most iconic images associated with the moon. Rising somewhere between 5 and 7 kilometers into the black sky, it creates a silhouette that looks uncannily like the sharp spire of a church steeple, or perhaps the dark fortress of the Eye of Sauron from fantasy lore. We are able to see such detailed views of these alien structures thanks to the data collected by NASA's Juno spacecraft. The probe arrived at the gas giant in 2016 with a specific 5-year mission to study Jupiter's atmosphere. However, after successfully completing that primary goal, Juno was repurposed and given a new lease on life to investigate the 4 Galilean moons. This extended mission led to 2 daring close-range flybys of Io, the first in December 2023 and a second in February 2024. During these maneuvers, the probe skimmed just 1,500 kilometers above the burning surface, capturing the most unique landscape in the solar system. The images returned by Juno revealed that Steeple Mountain is actually not a unique anomaly. The surface is dotted with these jagged, spiky mountains. The most massive of them towers 18 kilometers high, roughly double the height of Mount Everest. And what makes this really interesting is that, unlike Earth's mountain ranges which form in dense groupings, these structures on Io are all lone wolves. There are no ranges to be found, just these seemingly random peaks stabbing straight up into the air in total isolation. The sheer verticality and isolation of these peaks tell a violent geological story. Their shape suggests that these mountains did not form slowly over eons through the gradual collision of tectonic plates as ranges do on Earth. Instead, the evidence points to a much more aggressive origin. They appear to have burst from the ground with sudden, catastrophic force. The formation process is described as being reminiscent of the terrifying scene in the movie Alien, where the creature violently bursts from a chest. It is not a slow build, it is a rupture. Scientists are relatively certain that this phenomenon is inextricably linked to the moon's volcanic nature, but the mechanism is unlike anything we see on our own planet. As the lava flows and cools, it tends to cause the surface of Io to collapse, creating the massive depressions that become lava lakes. The theory is that this immense downward pressure into the crust acts essentially like a hydraulic piston. As a massive section of the surface sinks down to fill a void, the pressure forces the adjacent block of rock to thrust violently upward. To visualize this, imagine if every time a sinkhole opened up on Earth, a towering mountain instantly sprung up right beside it. That is the kind of bizarre natural process playing out here, a continuous cycle of rising and falling rock, driven by the relentless pull of Jupiter's gravity, which has been recycling the surface of Io for billions of years. Sadly, however, we may not see much more of this chaotic world for a very long time. NASA's Juno spacecraft, the source of these revelations, is slowly running out of fuel and is nearing the absolute end of its operational life. While the immediate future of Jupiter exploration is bright, the focus has shifted away from fire and toward ice. The European Space Agency's JUICE probe, standing for the Jupiter Icy Moons Explorer, was launched in 2023. When it finally arrives at the Jupiter system in 2031, it is slated to investigate Ganymede, Callisto, and Europa, looking specifically at their frozen surfaces and the liquid oceans hidden beneath. Then there is NASA's latest deep space probe, the Europa Clipper, Launched in 2024 with an arrival date set for 2030, this mission is, as the name suggests, directed specifically at the moon Europa. Its primary goal is to hunt for signs of alien life in the watery depths below that moon's icy shell. This leaves Io as the solitary odd one out. There are currently no missions planned to return to this volcanic world. This is partly because we simply didn't realize how fascinating and unique the landscape was until Juno sent back these images just a couple of years ago, and partly because the search for biological life takes precedence. Since Io definitely does not host aliens, it automatically drops down the priority level. However, with exciting new leadership at NASA and unprecedented new rocket technologies on the horizon, those priorities could shift. In the not-so-distant future, we may return to give this volcanic world the attention it deserves. Until then, Steeple Mountain stands as a silent, jagged sentinel over the chaos. That leaves Io as the odd one out. There is no probe heading there anytime in the near future. This isn't because Io isn't fascinating. It's largely because we didn't realize just how interesting the landscape was until we saw these Juno images just a couple of years ago. Also because it definitely doesn't have aliens, it automatically drops down the priority level compared to its icy neighbors. But priorities are changing at NASA. With exciting new leadership coming in and unprecedented new rocket technologies emerging, we could be studying the deep solar system just as thoroughly as we do Mars. Sometime in the not-so-distant future, we may return to give this volcanic world the attention it deserves. Until then, Steeple Mountain stands as a silent, jagged sentinel over the chaos.